Hello, we are Shathashika, Grace, and George, and we are here to present our solution to the Westinghouse EV challenge. Before we get started, let's introduce the problem. It is to design a system that tracks workers in real time and displays their current radiation exposure. This helps new workers actualize radiation risks and instills safe practices in nuclear facilities. The nuclear facility is mapped out beforehand with radiation sources and shielding to reduce the workers' exposure to radiation. A 3D radiation exposure map was created using the Python library Ursina. It assumes that the amount of radiation exposure is inversely proportional to the square of the distance. So essentially, the green blocks represent a low radiation level, while the yellow blocks represent an intermediate radiation level, and the red blocks represent a high level of radiation. We assume the radiation source to be inside here.
With a handheld device such as a Zebra or a GenM, workers will have a visual update of where they are within the facility, as well as where radiation sources and shielding are located. The device will display the 3D radiation map generated to help them visualize a real-life nuclear facility. A screen on the device would also show a summary of the current radiation exposure, which can be measured using a dosimeter. There are also visual indicators that will help the worker remember and follow behaviors that will limit unnecessary radiation exposure in real time. For example, it shows a route, which is a white path, that workers can take to minimize radiation. It ensures that they are taking a path far away from the radiation source and a path that maximizes the shielding. Afterwards, the workers can also review the simulated radiation dose and see where, when, and how much radiation they received at a certain location, and they can adjust their future behavior to improve with this information. It also provides the worker with a graph of their dosage intake. We program the system so that the data is sent to MATLAB in real time. MATLAB receives the information where it can be analyzed right away or saved for future reference. For example, this data can be used by the company to examine the training session and determine whether the worker is ready to enter the real facility.
To implement a tracking system in the workplace, it is best to install tracking beacons around the room. It is also important to ensure that the signals that the beacons emit will cover the entire room to provide the most accurate measurements. The beacons must also be installed in a high height away from obstacles. To deal with potential signal loss or blockage from the shielding, for example, we could install tracking beacons on the shielding and on the back of the workers. The tracking system could potentially use Bluetooth. Bluetooth beacons can broadcast signals up to 70 meters. It also consumes a small amount of power and requires little maintenance. A GPS tracker is not effective in this situation. This is because a GPS has a weak signal strength indoors as it has difficulty penetrating through the buildings. So the way that the tracking works is fairly simple. The beacons emit signals throughout the room. The user's device will pick up these signals and use them to pinpoint the user's location based on the signal strength. At the top of the screen, it displays the current amount of radiation the worker is exposed to. It also warns the worker when they are being exposed to more radiation than the recommended dose.
Overall, this system provides a very useful visual indication of training progress and gives the worker a chance to receive interactive and immediate feedback on their work. The data stored from the system would also give the company a crucial chance to review training, implement improvements to the sessions, as well as to determine whether workers are ready to enter the real environment. The system is also relatively low cost and scalable in the sense that it can even be implemented in real nuclear facilities to ensure that good practices are applied there as well. Overall, these visual indications via the handheld device will instill good habits within the worker and give them a much greater chance of success in the real setting later on. Thank you for watching.